A German engineer ran his hand along the American tank's hull and stopped. Not because the armor was thicker than expected, but because the welds were clean, uniform, repeatable. He'd been taught American manufacturing was crude, fast, cheap, quantity over quality. But what he was touching didn't feel crude. It felt like something made by a system, a machine designed to be copied perfectly again and again. And in a long war, repeatability is a weapon. It's early 1943 in North Africa. An American M4 Sherman is captured. In photos and later retellings, you might see nicknames attached to specific captured vehicles, names like War Daddy and similar labels. But the name is not the point. The point is what happens next, because the Germans don't just examine it on the spot. They move it. They preserve it. They treat it like evidence. The Sherman is taken to the rear for evaluation. No cinematic duel, no heroic last stand. Just the most revealing test of all. Does it keep working after the capture? After the stress? After the heat and dust and vibration? War is full of dramatic moments, but machines are exposed in boring ones, when no one is watching. And once the tank is secure, it doesn't become a trophy. It becomes an autopsy, because Germany has places built for this. The captured Sherman is studied at German proving grounds, facilities used to evaluate enemy equipment, measure armor, document mechanisms, and write technical verdicts. One of the best-known names connected to this work is Kummersdorf, a long-running test center where weapons and vehicles were examined and compared. And the expectation up the chain is simple. America builds quantity. Germany builds quality. So the engineers approach the Sherman like craftsmen inspecting a cheap imitation. They expect rough welds, bad fits, sloppy machining. They expect a report that makes everyone above them feel safe. Then they look closer, and the confidence begins to leak out. They measure, they mark angles, they record thickness, they document cast shapes, joints, bolts, fittings. And yes, by German standards, the Sherman is not a masterpiece. It isn't trying to be elegant. But that's not what scares an engineer. What scares him is the feeling that the Americans aren't chasing perfection at all. They're chasing repeatability. The same part made the same way, over and over, in numbers that don't care about ego. And repeatability does something raw brilliance can't do. It creates uptime. It creates predictable repairs. It creates a machine that can be replaced like a cartridge. Then they open it. Not the turret, not the gun. The working organs. Hatches, panels, layout, access. The Sherman is arranged like someone expected it to be serviced fast. By tired men, in bad weather, under pressure. This is the difference between a machine designed for a laboratory and a machine designed for a real army. Because battlefield reality is simple. Things break. And the side that gets vehicles running again tomorrow wins. German tanks could be exceptional, even frightening. But as designs grew heavier and more complex, the cost of keeping them operational often rose too. More specialized work. More time. More recovery effort. More parts pressure. Not stupidity, trade-offs. But trade-offs that become lethal when the war turns into replacement math. Then comes the moment nobody expects. They run the drivetrain. And the engineers listen. Veteran engineers don't just look at metal, they listen to it. Certain gear trains scream under load. Certain stresses announce themselves before the failure arrives. The Sherman isn't silent. But it has a steadier, less panicked voice. A hum that says this machine can take routine punishment. And once an engineer hears that, he can't unhear it. Because he knows what it means across distance, across weeks, across an entire campaign. In war, the quiet machine is often the machine that reaches the fight at all. Then they notice something else, something many people still miss. A stabilizer system on the gun mount, gyro-based. Not a modern shoot-on-the-move miracle, not Hollywood, not magic accuracy across rough ground, but it does something simpler, something practical. It helps keep the gun steadier in elevation while moving, so when the tank stops, the gunner settles faster. Seconds matter. The first accurate shot in a tank fight often decides everything. And here it is, on a mass-produced medium tank. Again, not perfection, a practical advantage that lives in the moment you least want to lose time. And yes, crews didn't always use it the same way. But its presence reveals the American mindset. Give the crew tools. Make the machine forgiving. Make average performance repeatable. When armies compare machines, they love demonstrations. Obstacle runs, slope climbs, staged trials where a crowd can feel the result. And staged trials are dangerous because they reward the dramatic. A heavy tank can win a short test and lose a long war. A complex machine can look superior in a controlled moment and collapse under months of maintenance pressure. Engineers understand this, but decision makers often don't, because decision makers are human. They love the story that flatters them. So while the room cheers a sprint, the engineers watch the marathon. They watch how the vehicle is built to be repaired. They watch how parts are standardized. They watch how systems are arranged so a tired mechanic can reach them. And slowly, the uncomfortable realization forms. Even if the Sherman is not better in an elegant sense, it is built for the kind of war that is already happening. The war where broken vehicles are normal. The war where the winner is the side that keeps field strength high. Albert Speer, the Reich's Minister of Armaments, was deeply involved in the struggle to increase output and rationalize production. There are photographs and accounts of senior German officials inspecting captured Allied equipment as part of understanding what they were facing. And you don't need a speech to see the threat, because the threat is not one tank. It's an industrial method, a way of building war that scales. Here's the split, clean and brutal. One philosophy prioritizes reliability, maintainability, standardization, scale. The other often prioritizes performance, protection, firepower, technical superiority. Both can build terrifying machines. But only one keeps numbers high when the war becomes replacement math. Because war doesn't reward what's impressive. War rewards what's present. A tank in a factory is not power. A tank in a workshop waiting for parts is not power. Power is what rolls today, right now, and again tomorrow. Ask crews, and you hear it differently. When a machine starts reliably, runs reliably, and can be kept alive by ordinary maintenance, crews trust it. They move, they show up, they fight. When a machine is brilliant but fragile, powerful but demanding, crews fear it in a different way. Not fear of the enemy, fear of the breakdown, fear of being stranded, fear of watching the war drive past them while they wait for recovery and parts. That kind of lost propaganda can't hide, because it happens behind the lines, quietly, and it kills offensives before they begin. By the later years of the war, reliability and maintenance strain became a serious operational issue for multiple armies, especially when complex designs were rushed, supply chains were stressed, and fuel and spare parts were unstable. Repairs take time, recovery takes time, spare parts take time, and time is the resource you never get back. You can win an engagement and still lose a campaign if your vehicles can't stay operational. You can knock out enemy tanks and still lose a war if the enemy replaces them faster than you repair yours. That is the cold arithmetic engineers feel under their fingertips. Not ideology, steel, systems, throughput. So what did that captured Sherman really show them? Not that it was invincible. It wasn't. Not that American design was genius. It was often conservative, deliberately. It showed something more uncomfortable. That America was building for mass war, where maintenance is constant, parts are standardized, crews rotate, and the front is fed by an industrial river. Germany could build masterpieces. America could build a flood. And in a war of machines, the flood wins. The engineer takes his hand off the weld seam and realizes the truth. This tank is not the enemy. This tank is the future. And the future is already arriving, one identical machine at a time.